As you can see, previously we've already have process stubs mounted to this piece of equipment. In the field, it's probably going to come with crimped off process tubes. For training purposes, we already have the process tubes on. So we have our suction process tube and our discharge process tube off the dryer installed, as indicated by our red tape. We know that there's flammable refrigerant inside this unit. So the first step will be to discharge the refrigerant. If you have a compressor that is functioning and working, we recommend that you warm the unit up for about 5 minutes prior to starting this process. That'll help to break the bonds between the refrigerant and the oil and allow you to get more of the refrigerant out of the system during the discharge process. If you're just replacing an evaporator or a component and you can run the compressor, you can use the compressor to help aid you in the discharge of refrigerant. If it's a non-functioning compressor, obviously the ambient air temperature is all you're going to be able to rely on, and you'll do a passive type of recovery. So I want to make sure that this is all the way back seated. It even says open close on the back of the valve. This will prevent us from installing this and the Schrader core being depressed. So all I have to do is go ahead and run my core, get it nice and snug, and then the system's ready to go. The Schrader core is still closed. Obviously no refrigerant's coming out. We're not indicating anything on our leak detector. We can go ahead now and hook our discharge hose up. Again, if we were discharging to the exterior of the home, this is our discharging hose, which comes with a weighted end. We can go ahead and hook directly to the unit, run the hose outside, start the compressor, and start the discharge process. In this scenario, we'll be using a standard accessory hose, and we'll be charging to a recovery bag. So the first thing we'll do is we'll lay out our recovery bag that we'll be using today. Obviously with recovery bags, they're temporary recovery cylinders or bags in this state. The bag does need to be inspected, so periodically you do want to check the bag to make sure that there's no rips or tears in it. This is a double lined bag, so it is very durable. Go ahead and hook into the bag, and we'll leave our valve shut. And again, a valve isn't necessary, but I prefer to have anytime I can have a quick access shut-off valve, I prefer installing them, so I do keep that on my hose. It lets me isolate to the bag quickly. So we're going to go ahead and thread in our Schrader core depressor. This will allow my refrigerant to flow to the hose up to my valve. And after I open this valve, you're going to hear the refrigerant start to discharge quite rapidly into the bag. That is one thing I like about utilizing a recovery bag, is because you can hear the refrigerant and essentially the state of emptiness of the refrigerator, so to speak, just through the auditory tone. So it is helpful once you become experienced as a technician to listen. So I'm going to try to be quiet for the remainder of this portion so you can actually hear the refrigerant flowing. All the way front seated, and then as soon as I open this valve, we should start to hear the refrigerant flow. Now that you can barely hear the refrigerant flow, this is usually where I'll close my quarter turn valve and I'll let system pressure kind of build back up a little bit. Since we still have the capillary tube not pinched off, there's still a little bit of a Venturi effect, meaning the refrigerant will flow through the system, through the capillary tube, and take some time to build pressure up. So as I open my quarter turn valve again, you'll hear another sudden surge as pressure has built up in the system. And then I'll shut it again. And I'll continue to do this a few times until my system no longer discharges. Now to aid in this, since we have process tubes on here, we could attach our suction gauge and monitor our suction side pressure as well. But as you get experience with using the recovery bag, a lot can be told just by the auditory. So here we go again. I'm going to open the valve. You'll hear another discharge. The other thing you can do while you're discharging is you can reach into the unit, tap the compressor a little bit. That'll help free some of that bond between the oil and the refrigerant. There's our capillary tube. So normally we'd take our pinch-off pliers if we were going to actually replace the dryer, and I'd simply come into the cabinet and I would just pinch off the capillary tube. That'll direct all refrigerant flow through my hose and into the recovery bag. If we pinch it off, it can no longer go into the system. It has to come through the process tube, through our Schrader port depressor, through our charging hose, and into our recovery bag. So once I open this valve again, you should hear another discharge since we haven't been discharging the bag for a little bit. And as you can see, it continues to get less and less and less as we discharge the unit with the aid of the compressor, getting to the point where I hardly hear anything at all, which is telling me as a technician that it's safe to go ahead and stop the recovery process and go ahead and open up my system and perform any component replacement that I need to. Again, as an added safety to technicians, especially one that is new or just isn't using a recovery bag, you can always hook your suction gauge up to the suction port and monitor the suction pressure to ensure we're getting to 0 or into a vacuum. If you would like to hook a suction gauge up, we already have a service port here, so we can always monitor our system pressure by hooking our suction gauge manifold. Now keep in mind with R600, if we weren't actually recovering, I would not want to hook this gauge up because again, R600 is on a vacuum on the suction side. If I hook this to a functioning system without evacuating my manifold first, I would basically suck all of the air and non-condensable gases directly into the system. So keep in mind, for troubleshooting purposes, you will need to evacuate your gauge set before you ever hook it to the low side of the system. So I have my suction gauge manifold all hooked up. Our suction hose goes to the bottom of the gauge manifold. And I'm not going to use a Schrader core depressor, but I do need to ensure that the hose has a Schrader depressor installed so that I can actually get a reading. And you can see the gauge instantly fell into a vacuum. And that's what I was saying. Even though I didn't have a gauge up, I was confident that we'd removed the refrigerant just by the sound it's making in the bag. And of course, that's going to come with some experience. So until you get that confidence, go ahead and hook your suction gauge up. It's not going to hurt anything. We're recovering the unit. Any air and nons is going to be sucked into the system and discharged into the bag. We'll perform our service and we'll evacuate everything anyway. But this gives you that extra safety of knowing what the system pressure is. So our unit's back on and running, and you can see it's starting to pull down even further into a deep vacuum because there's no refrigerant left. Almost down to 29 inches. So the compressor is in great shape. And one more time, we'll go ahead and do a discharge to the bag, and you could hear nothing, which is obviously indicated by the gauge. We would expect to hear no more gas discharge. But that is basically the complete discharge or recovery of our R600. So at this point, I'll leave my valve and hose assembly attached to the bag. I'll simply back seat my Schrader core depressor, and then I can safely disconnect the whole assembly. With this whole assembly now disconnected, I have no fear of loss of refrigerant. I can take this bag outside into a safe area that's free of any ignition sources and discharge the R600 into the atmosphere. Okay. So here we are outside. We've come to a safe location with limited foot traffic and no ignition sources, so it's safe to go ahead and tear down our recovery bag. So the first thing I'll do is remove my hose, and I want to open any of the valves just to make sure that the R600 can flow freely through the hose. Then the next step I'm going to do is I'm going to need to remove the Schrader core that's in this bag. It's there to prevent the refrigerant from discharging out. So I'm just going to take a Schrader core removal tool, and it's actually a torque tool as well. And I'm just going to simply remove the Schrader core. And then remove the core. So I'll just turn the bag over. Again, remember, refrigerant's heavier than air. And just start rolling it up. Something to note while we're getting the refrigerant out too, that the bags only hold just over 12 ounces. It seems like a really big bag, but it doesn't hold a lot of refrigerant. The whole key with a recovery bag is that it should never become pressurized like an actual recovery cylinder. So do pay attention to the volume of the recovery bag that you're working with and how much charge is in the appliance. We just want to get as much as we can. I do regular maintenance every now and again. I will put our bags under a vacuum just to pull everything out of them, and also to ensure that there aren't any holes or leaks in it. It's a pretty effective way to leak test your bag, since you don't really want to pressurize it, since you could just weaken the joints. And that's it. So we're at the point now, we've done our preliminary checks. We've gone ahead and recovered all of the refrigerant from our appliance. So now we're getting into the actual charging. So we've replaced our components, we've installed a new filter dryer, and we're going to go ahead and charge the system. Before we do that, we're going to need to at least get our entire hookup of our charging kit, and then we're going to do an evacuation so that we can test all of those connections. So we'll open up our kit. First thing we'll do is we'll get our low side gauge out, and we'll take the hook and we'll go ahead and get it installed. And I'm just going to mount it here for now. So just like a typical gauge manifold, the bottom port is the port that connects to our appliance, and any of the side ports is for the transfer of refrigerant, or it's for hooking to the other gauge. Now, quite often technicians only want to use one gauge. If they're not troubleshooting, they're simply going to be just recovering or charging. They may only want to use the one gauge. If you know the system has no restrictions and you just did work on it and it's maintenance, you could only do one hookup. But today we're actually going to hook both the low side and the high side up so that you can see how to deal with the liquid refrigerant that will get inside the gauge manifold for your high side. All of that refrigerant does need to go back into the system. Remember, R600 is very small amounts of refrigerant, and every one of these appliances will be critically charged. So we do need to account for all of the refrigerant going into the system. We do want to notice on this gauge, the resolution on the low side of this gauge is much larger than you typically see for a standard refrigeration manifold. Keep in mind that with R600 running constantly in a vacuum, you want a higher resolution on this low side. The other thing you want to notice is that the max pressure that is on this gauge is 45 psi. So if you try to hook this to a 134A system, you very well could overpressurize the gauge. So keep in mind that both this low side gauge and our high side gauge are going to be utilized for R600 service only. If you put it in, again, the range on the high side, you're looking at 140 psi, and the resolution for the vacuum is still what you would typically see on a normal gauge that you're used to for 134A. So our kit will come with 4 accessory hoses, and this is for mounting our gauges to one another as well as to the system. And I'll go ahead and I'll grab a Schrader core depressor. I want to make sure that the hose without the Schrader depressor is hooked here. Then we can go ahead and install to the other side of our manifold. And I'll do the same thing with the high side manifold. And I'll hook its Schrader port, Schrader depressor up, and I'll hook to the bottom of that gauge. I do it like this just so that I know instantly where the hookup and which hose goes to the appliance. Some people do color code these hoses. They prefer to have red tape to go here and red tape and then red tape. So it just keeps it easier for them for the hookup. But eventually with practice, you really don't need that. So the next thing we will do, we'll be charging this unit. Since it's only 1.2 ounces of refrigerant, we're actually going to be charging in a vapor, so we'll leave our bottle upright. If this had 40 grams or higher, we would actually need to charge in a liquid because condensation will start to form on the bottle. But since this is a relatively small charge, we'll actually be charging in a vapor today. The next part is our T portion. This is going to create a manifold to help us hook and convert our single gauge manifolds essentially into a 4-gauge manifold set. So all I have to do is hook to our T. We have one double male connection, which will go on the female side of the T. And this will be my evacuation port, and this will become my refrigerant supply port. So this will basically, the large accessory port or the 3/8 line that's on a 4-valve manifold and the 1/4 inch line that you typically see on a 4-valve manifold. And that's what we've recreated. We need to hook our high side and low side gauges together. So there is a Schrader core inside here. So I want to make sure, again, I use the Schrader core depressor to hook to the accessory port on my suction gauge manifold. And then this will just hook to the accessory port on the high side gauge, effectively linking them together. So now this has become just like a standard 2-valve manifold, but we've used a hose to bridge the two together. The next hose that comes in the kit is our charging or refrigerant hose. It does have a check valve installed, and it does have a direction of flow. So we want to make sure arrow is directional flow is this way, which means it's going to flow from our bottle to the appliance. So I want to make sure that arrow is lined up in that direction. And then since we're doing a vapor, come to the back side and I just hook to my bottle. Make sure my valve is closed, and I can simply thread the bottle onto my can. Keep in mind that the can adapter is made from aluminum and the can is steel. So if you just swing this can onto the adapter, you have a very high potential of stripping the threads in your can adapter. So always be careful when you're actually installing the adapter. And again, that's going to hook to the refrigerant side of my manifold. I'm going to come over to my vacuum pump and get my vacuum hose. It is recommended that you put a ball valve on your accessory hose you use for evacuation. That will allow you to secure the valve while the system's under a vacuum, preventing any oil from being drawn into the hose and contaminating your hoses. And I'm going to hook that to the vacuum portion of my manifold. Make sure all the connections are good and snug. And then we have my final connection hose, which we simply hook into the side port of the suction gauge manifold, ensuring I still have a Schrader depressor, because there's going to be a Schrader core if it's not been removed on the side. In this case, the Schrader core depressor has been moved to the side. So we still have a Schrader depressor, we're still good to go. So this is the entire hookup of the system, and now I can simply take my high side gauge, which we've already have hooked up. My Schrader core depressor is already attached. The only thing I want to verify is that I'm all the way in the back seated position. So all the way to the left, it'll stay closed right on the back side of the valve. And then I can install Schrader core depressor. Again, the valve core has not been depressed. It's not open to the system yet. It's simply acting as a closed valve. That's the great thing about Schrader core depressors. You basically turn a Schrader core into an open closed valve through the use of this tool. And again, I'll take my suction. So again, making sure I'm all the way back seated on my knob, and we simply install it to our suction side process tube. And there you go, nice and snug. At this point, I'm ready. I have both my gauges are hooked up. Both side valves are secure. I don't need anything going to my vacuum pump at this point, and I don't need anything coming from my refrigerant. So I make sure that all my valves are closed at this point, and we're all hooked up. What I want to do next is check all my connections. Since we have quite a few connections and hoses here, I'm going to go ahead and run my vacuum pump and then set my low pressure gauge pointer to wherever the ultimate vacuum lies. So whatever the capacity of my pump is should indicate on the gauge. We'll let it run for approximately 5 minutes, and then we're going to shut the pump off and do a standing vacuum or vacuum rise test to see if we have any leaks anywhere. There's no point getting into the system and then determining you have a leak in your hose or your setup. We want to find that right away in the evacuation process, or it could take extremely long amount of time. So that, we'll switch our pump on. I've got a valve on the hose which is open, so my vacuum is coming through my hose. I'll go ahead and open my manifold. It comes up to my low side gauge. I need to open my valve manifold. You see it instantly drop down to a vacuum. I'm going to do the same thing on the high side. Instantly drop down into a vacuum. Then I'm going to go ahead and open up. We're going to make sure my refrigerant bottle valve is shut, and I'll open my port to the bottle. Not pulling any refrigerant, but I am evacuating all of my hoses up to the point of the bottle. Make sure those connections are snug as well. And when we're at this point, we just want to take basically a quarter turn in on our Schrader removal or Schrader depressors. The reason for that is if there is a small void in here, and when it's fully backseated, there's no vacuum being applied to our last connection, which was the Schrader core depressor to the process tube. By front seating it, I allow the evacuation to occur all the way to this point, therefore testing all of my connections. And then I'm going to set that reference pointer right on top of my needle on the low side gauge. Since I've already established the pump's output, I know that a dry system after time should reflect the ultimate vacuum output of our vacuum pump. And what I'm doing is I'm leak testing all of my connections now. All I have to do is let the pump continue to run, isolate the valve at the pump itself, and make sure we don't get any rise in vacuum. Usually 5 minutes is adequate. If you see no rise, all of your connections are good, your hoses are tight, and you're ready to begin the evacuation process. So at this point, I don't see anywhere where I've had a rise. For video purposes, we're going to cheat a little bit, and we'll advance from the 5 minutes. So we'll go ahead, open our pump supply valve. So now we're pulling vacuum again to the system, and I'll go ahead and open front seat my Schrader core depressors. And we do that a little slow, just in case there was any residual refrigerant trapped in the system. We don't want to slug our vacuum pump. I'll do the same thing on the, well, that was actually the high side, so we'll do the low side now. No movement on the gauge, we're good to go. So both gauges are into a deep vacuum. At this point, we'll do our standard evacuation process, generally about at least 15 minutes. Good indicator on these gauges is going to be our reference needle. It will allow us to know when we've pulled down to a deep vacuum. If we can get to the ultimate vacuum of our pump, we know that this system is fully recovered. If you have a micron gauge, you can always hook a micron gauge to the system, which is recommended, so that you can get a stable 500 microns of dryness in your system. Again, our evacuation will take approximately 15 minutes, and we want to make sure we don't see any rise in the system. Generally, after pulling for about 5 minutes on the system itself, I'll go ahead and do another standing vacuum test so that we can see that the system itself doesn't have any leaks. Because we've done repairs on this refrigerator, we put some lock ring connectors on to put our process ports in. So essentially, we want to test all these connections as well. So I'll do another standing test on the refrigerator and make sure, again, I generally wait at least 5 minutes and make sure that we don't have any rising vacuum. Don't see any rising vacuum, so we'll continue with our evacuation process. And that's done by simply opening the valve back to our vacuum pump and allowing the system to continue to evacuate. Again, the whole time this operation is going, we still have our fan running and we're still monitoring for leaks using our leak detector over here. All of those devices should be in place while you're performing this service. Okay, so we've completed the evacuation process, and at this point we can move forward with the charging of our unit. Everything is going to stay hooked up exactly the same. The only thing we'll change is we're going to go ahead and close our liquid side of the system because we're not going to be charging liquid at this point. So now we can go ahead and secure our ball valve for our evacuation hose and go ahead and shut off the pump. And at this point, we can shut all of the valves on our system. By shutting all the valves, we're essentially saving all of the vacuum inside. We're guaranteed that we're not going to lose our evacuation. We shouldn't have any leaks, so this is the reason I shut all the valves. We'll be charging in a vapor today. We'll have our scale here. We'll zero out our scale. Currently have it set to ounces so that we have 1.2 ounces of refrigerant of R600 needed for this unit. So we'll be delivering it from our bottle through our check valve, which our direction arrow is pointing away from the bottle, so refrigerant flow will be from the bottle towards the unit. And then I just take the check valve and sit it in the kit, and that helps prevent the scale from being moved around a lot, and we can get a more accurate reading. Try to keep it in the same spot. Some technicians actually put a blue or a circle around here so they can keep their cylinder in the same spot every time. And after we moved it, we want to zero it. So at this point, we're able to open our refrigerant bottle, and we'll go ahead and deliver the gas through our suction side. So I'll go back and reopen our suction side and our suction side manifold, and then we'll regulate everything from right here as we push our charge in, looking for 1.02 or 1.2 ounces. And once we get to the point where we don't see any more refrigerant being drawn in, we'll actually turn the unit on and allow it to draw the remainder of the refrigerant in. Prior to doing that, I will secure my refrigerant inlet valve and then turn on the refrigerator, which it does have a slight delay, so we'll have to wait for that to kick in. Unless that gauge starts to come down, and we'll open up our refrigerant flow again. Once we get close to the full charge amount, we'll start to close our valve and meter it in, just allowing the scale time to equalize between little charges. And this will allow us to ensure we hit the most accurate charge we can, which is 1.2 ounces. So we're at 1.0. One.
Let me get the red one as well.
It won't change right now. Shouldn't be.
It's just bouncing a little bit.
And we hit 1.2. Now if we're troubleshooting, we want to see the high side gauge. We'll actually have to get a high side reading, and we'll need to do that by actually opening our Schrader core depressor. So we've hit our 1.2 ounces of refrigerant into our refrigerator. So at this point, there's still going to be refrigerant inside my charging hose, and the blue charging valve is closed. So I need to get this tiered amount of refrigerant into the unit, and that's simply by closing the refrigerant bottle or our bottle adapter and closing this valve. Now no more refrigerant can escape the bottle, so once I open my charging valve, we should see a little spike on the low side gauge, and then the remainder of the refrigerant is pulled in. And we close our valve. And now it's safe to disconnect the bottle from our bottle adapter. So at this point, we've identified that our high side is operating at a correct pressure here. We have 70 psi on the high side, which is very typical for a small R600 unit. At this point, we're ready to disconnect, so I need to come to my high side gauge, and I just need to back seat my Schrader core depressor. And then remember, there's a void here, so if I fully back seat, I won't get the little bit of refrigerant that's going to be caught between the fitting and the actual stem of the Schrader core depressor. So I'll simply turn it in about a quarter turn. That'll open this area up, allowing me to recover all of the refrigerant. So we'll come through. I'm already tied to my suction side. I'm still reading. My suction side is still open from the charge process earlier. And all I want to do is slowly crack this open and draw all of the liquid refrigerant out of my gauge manifold. It should essentially match my low side gauge. Once we're in a vacuum like this, I can simply back seat my Schrader core again. I can isolate my valve manifold, and I can remove the Schrader core depressor safely. Always put your Schrader cap back on if you're going to leave the process stubs in place. If you want to permanently leave these in place but render them useless to a homeowner or another technician, or for R600 liability and safety, you can always put some lock prep into the end of the Schrader core and onto the threads and install the Schrader cap, and you have just rendered that port unusable and would be just as good as if you would put a stopper on the end of the process tube. If you like to leave the Schrader cores here for future services, that would be up to your company policy. I'd like to thank everyone today for watching our training video, and I'd like to say a special thank you to Sub-Zero for supplying the under-counter refrigerator that made this video possible. I also hope that the information that you've learned and gathered in this video is going to be beneficial to you in the safe handling of hydrocarbon and other flammable refrigerants.